Welcome and settle in. Imagine yourself on a quiet night shift, keeping gentle watch at a radio telescope, listening to the universe and not hearing anything at all, just the soft murmur of instruments and the steady breath of the earth turning under a sky you barely need to look at. You sit calmly, eyes soft, shoulders loose, letting the hush of vast distances wrap around you like a blanket, while the dish outside moves with patient grace, following a path written in coordinates older than clocks. How sleepy are you on a scale of 1 to 10? If this kind of calm keeps you company, you can like this video and subscribe so more sleepy science drifts your way. And if you want a longer journey, there is a playlist in the description that can keep you learning gently while you drift. Now imagine yourself in the control room, a comfortable space filled with low red lights that do not glare, with soft fans and a faint scent of clean metal and dust that has settled for years. The chair has a steady weight. The desk is stable under your resting hands. And on the screen, a waterfall display slides slowly downward, lines and faint patterns dissolving into the next moment. The dish outside is so large that it seems not to move at all, though you know its motors are humming. You can almost feel the slow geometry of the sky mapping itself to the arc of its motion. It moves in right ascension and declination, and the earth supplies a sidereal rhythm that is older than your thoughts tonight. You glance at the time and listen, and it is not like listening in air. It is listening to a temperature, to a field. It is listening to the noise floor, the quiet hiss of the cosmos at radio wavelengths, where the word sound is only a metaphor. The gentle rhythm continues. On nights like this, you keep watch over the stability of a system that never raises its voice. You monitor system temperature, calm and low, a few tens of kelvins above the cosmic microwave background, which rests around 2.725 kelvins, like a warm whisper left over from a very old beginning. You check the calibration noise diode, a comforting little tool that injects a known fuzz into the receivers to make sure the scales are true. A switch flips softly, and the plot wavers just as expected, changing by a small, measured amount. You nod to yourself, the same nod others have made for decades in rooms like this, in observatories that are often far from cities, among hills or deserts or high plateaus where air is thin and dry and the radio spectrum is a little more pure. Sometimes you can imagine the dish as an enormous ear pressed to the very softest pillow, listening for a breath that might not come. And still, the listening brings a kind of peace. The night begins with a drift scan. You set the telescope at a fixed declination and let the sky glide through the beam as the Earth turns. The beam width depends on the diameter of the dish and the wavelength you have chosen. At 21 centimeters, the neutral hydrogen line, the dish sees a slice of the sky, narrow, like a quiet glance. The beam passes slowly over the galactic plane, where the map of hydrogen is rich and layered, and then over high galactic latitudes, where the gas is thinner and the background quieter. The signal comes not as a melody, but as a spectrum, a curve that rises and dips, shaped by clouds of hydrogen in motion relative to you and relative to the center of the galaxy. Doppler shifts shade the line into a gentle hill, sometimes split into multiple peaks, as different clouds pass through your beam with different velocities. You let the integration run longer to lower the noise by the square root of time, a simple kindness to your data and to your mind. The longer you wait, the more the random fluctuations settle down, and the line, which at first seemed too faint to trust, begins to feel like a steady, familiar thing. Somewhere in the room, a clock ticks softly, but mostly you hear the fans and the quiet rush of air conditioning. The receivers need to be kept at a stable temperature, their own little climate, to keep the noise from rising. The cables, thick and patient, carry signals down from the feed at the focus, through filters and amplifiers, and into digitizers that take the continuous flow and parcel it into discrete samples, ready for Fourier transforms that lay out the energy across frequencies like a field of grains. You watch the waterfall spectrogram scroll. It has color scales you set to be gentle on your eyes, pale blues, muted greens, a faint amber line where a bright source drifts through. Sometimes you point to a strong calibrator source, like Cassiopeia A or Cygnus A, and in that case, the display brightens, and you measure the response and write down a note in the log. The log itself is as much a ritual as a record. You enter time in UT, write down the coordinates, the receiver band, the bandwidth, the resolution in kilohertz, the integration time, the weather, the wind, the state of the ionosphere, if anyone has alerted you, and any known sources of interference. The handwriting feels calm, even if it is typed, because the words move slowly, unhurried, regular. The night shift at a radio telescope is full of intervals that feel like the padding of sleep. There are checks to be done and small tasks that keep the rhythm slow and even. You point at a patch of sky where a pulsar might pass through your beam if you are lucky, and then you look away from the screen to give your eyes a rest. Even if the pulsar is there, you might not see it in a single sweep. Off the shelf, the pulse is scattered by interstellar plasma, delayed differently at different frequencies. The dispersed signal is like a chord spread in time, high frequencies arriving sooner than low. To bring it into focus, you need to de-disperse, to apply a correction in the frequency domain that aligns the arrival times so the pulses add together cleanly. But tonight is not about the chase. Tonight is about the quiet work of setting upper limits, of collecting time as data, of saying that nothing above a certain strength was present, which is itself the kind of knowledge that builds patiently. You breathe with the hum of the room. You turn to the window, where the silhouette of the dish stands against a grey-scale slice of sky. It is dark enough that the dish looks like a curve cut out of soft velvet, barely moving, although it is always in motion, a degree here, a fraction there. Following the command sequence you cued gently at the start of the shift. Outside, the motors are slow and smooth. Encoders measure angles with steady precision, and the pointing model corrects for refraction, gravity, sag, and the slight imperfections that come from a structure that is also a living mechanical body. The control software is not in a hurry. It waits until coordinates change by a small threshold, and then it nudges. The stars do not notice. The dish notices. You notice. The spectrum in front of you has a handful of familiar artifacts. There is a notch where you have placed a filter to block the strongest mobile transmission, and a narrow spike that is easy to mask out because it is so thin, too thin to be astrophysical. There is a faint line that drifts in frequency during certain hours as satellites pass, each one identified in a catalogue the observatory keeps. Mitigation is as calm as a breath. You draw small masts, you flag pockets of time, you let the flagging run automatically, and then you look again at the data with the contaminants set aside. In the remaining expanse, the universe speaks softly, mostly in whispers that register as temperature, not voice. You are listening to patient fields with a patience of your own. You might recall that radio astronomers measure flux density in Janskys, a tribute to a person who listened early and carefully. 1 Jansky is a tiny unit, 10 to the minus 26 watts per square meter per hertz. A lot of sources you measure are many Janskys, and many are fractions of one. The scale is a comfort because it is meant for faint things. The numbers feel small but friendly on the page, manageable, not imposing. You note them calmly in your log. There is no hurry and no surprise, just quiet collection. Imagine yourself gently tracing the shape of the spectrum with your eyes. The edges of it feel like the edges of a cloud, smooth and soft, and you can almost feel how a moving cloud of gas far away adds a bit of brightness at a velocity corresponding to its motion along your line of sight. You begin to think in velocities rather than raw frequencies, because the Doppler correction is one of the first things you apply, mapping frequency to speed. It is easy to imagine clouds sliding through a gentle wind of the galaxy, their motions layered atop the spiral structure and the slow rotation of the disk. After the first hour, you stretch your fingers and take a sip of something warm, and the scent is faint, not too strong, so it does not pull you from the edge of drowsiness. You drift back to the screen and let your eyes fall to the waterfall again. Imagine that the colors are so neutral they barely register. A pale tapestry moving downward at a pace that matches your breath. Now and then, you click on a bright speck and read off its frequency. You toggle a setting and the resolution slides, trading detail for sensitivity or sensitivity for detail, and you smile at the way trade-offs are often gentle, like a seesaw that wants to settle in the middle. The universe is not trying to rush you. The gentle rhythm continues. At the heart of it all is the notion of signal and noise. Noise is not an enemy here. It is a companion. It is the soft hiss of thermal motion in the electronics, the faint lapping of atmospheric emission, the distant brilliance of the cosmic microwave background, the quiet static of the wider universe, and the uncertain jiggle of random fluctuations. In statistics, the comfort comes from the idea that if you wait and you average and you let time pass, fluctuations cancel and the mean reveals itself. Integration time is the simplest spell you cast. You stack 1 second onto another, and then 1 minute onto another, and then an hour, and at every step the uncertainty shrinks. You can almost see a curve, like a smooth slope trending downward on your plot, steady and reliable. You look at the curve and feel your shoulders let go just a little more, because the discipline of patience is its own kind of rest. The quiet you hear is not empty. It is rich with the possibility of being shaped. You check the status of the cryogenic system that cools the low noise amplifiers, making sure the temperatures sit where they should. You read the readouts without effort, numbers that do not change dramatically. The vacuum levels are good. The compressors hum. The doers are content. It is a good night to take long exposures in radio, which is a different kind of exposure, but the metaphor is still gentle. You settle into the feeling that nothing will surprise you, and that this is what the night is giving you as a gift. There is nothing to chase. There is only the time you keep in the margins of your log. You quietly sketch the pattern of the array if your observatory has multiple dishes. Each baseline between 2 dishes becomes a pair of ears listening together, producing an interference fringe that is more precise than either alone. Cross-correlation feels like watching 2 calm streams merge into a wider river, their ripples combining into something that speaks softly of where the original ripples came from. In the correlator, voltage streams sampled at high rates meet in a patient mathematical operation that multiplies and averages, producing complex visibilities indexed by baseline and frequency. The word complex is not dramatic here. It just means 2 numbers, real and imaginary, the sine and cosine that translate to amplitude and phase. From those, you make images not by painting, but by inverting a transform, letting the interference fringes become spots and edges in a map of the sky. None of this needs to hurry. Even the inversion is gentle when you think of it conceptually. The sky has put out light for eons. Your transform can take another minute if it wants to. There are pages you could turn to in a manual for comfort, not because you need to, but because manuals written by patient hands can be soothing. They explain bandpass correction, which is the practice of flattening the spectral response so that the instrument's own shape does not add curvature to the data. They explain polarization, where the field has a preferred direction and your feeds can measure horizontal and vertical, or left and right circular, and you can combine them to understand magnetic fields far away. They explain how Faraday rotation can twist polarization as the signal travels through plasma threaded by magnetic fields, with a twist angle proportional to the square of the wavelength. a simple rule that makes you imagine the light slowly rotating as it walks across the distances. Even the math in these manuals carries a calm. Integrals look like elongated loops, and sums look like beads on a string. You do not need to compute them now. You only need to be comforted by the knowledge that they are steady and have guided people through this work for a long time. You switch to a different band gently, moving from L band around the hydrogen line to a higher band where the sky is a little cleaner for some kinds of searches. Each band has a character, like rooms in a quiet house, each with its own tone. At lower frequencies, the sky is warmer, the wavelength is longer, the beam is wider. At higher frequencies, storms in the atmosphere can add their own whispers. Water vapor, speaking in lines you learn to avoid on certain nights. But even that is not disruptive. It is just another line in the log. You check a weather station that seems to have taken a vow of calm. Wind speed is low. Humidity sits lightly on the numbers. Temperature falls by a fraction of a degree each hour. The night gently clears. At some point, you align the telescope with a standard candle of the radio sky, a source whose flux is well tabulated. You perform a calibration that puts the scale of your measurement into a more absolute framework. The software asks you to mark a few points, to fit a gentle polynomial to the bandpass, to subtract the baseline, to separate the line from the continuum. You click, you confirm, and in exchange the plot becomes more polite, straighter where it should be straight, and most of the structure that remains is the sky itself. You lean back slightly, and the chair offers the slightest resistance, almost imperceptible, and then gives, so you are supported. The gentle rhythm continues. Imagine stepping outside for a moment. The air is cool. The dish is darker than the sky, which is soft and low in contrast, sprinkled with stars that are not twinkling very much at all because the atmosphere is calm. Somewhere a coyote or a fox might pass, but you do not see it, only the suggestion of movement at the edge of your attention, and you decide that it is the wind touching the grass in the gentlest way. The dish turns a fraction more, its gantry lights dim red, so as not to disrupt anyone's dark adaptation. You put your hand on the railing and feel the steady chill of metal. You breathe in, and the smell is of dry earth and faint oil from something mechanical that has worked for years without complaint. There is a distant rumble that might be a truck far beyond the hills, but it fades quickly, and the only constant is the whisper of air and the soft vibration of the machinery that keeps things steady. Back inside, the display shows a piece of the galactic plane passing. The map of the galaxy at radio wavelengths is like a hush painted with invisible ink. Spiral arms reveal themselves in hydrogen maps as arcs that you can follow by eye if you want to be precise, or by feeling if you are content to drift. The central molecular zone is bright in other bands, but here it is just one part of a larger picture, arranged with symmetry and slight asymmetry, like a piece of cloth folded and unfolded over time. You think about distances without effort, Light years blend into kiloparsecs, and the numbers stop feeling large. They become scenery. You let the distances flow past you in thought as the sky flows past the beam in reality. Far away, a pulsar spins with the regularity of a metronome for someone else's music. Tonight, here, you mark only that in this place and at this time, no pulses above a certain strength pass through. That sentence is surprisingly lovely in your mind. It is a sentence that science uses when it is being its most careful self. It says that not seeing can also be seeing, if you know how to say it clearly. When you do think of a fast radio burst, if you do at all, you think of a brief light in the data, a sharp streak in the waterfall that lasts milliseconds and has a dispersion signature. But you do not pursue it. You simply note that nothing like that has appeared tonight. You might think of SETI as well, the search for signals that are narrow and unnatural, a pure tone where nature mostly prefers broad strokes. The software quietly looks for such narrowband spikes and labels them if they occur. When a spike is flagged, you cross-check against catalogues of satellites and terrestrial transmitters. Most nights, all the spikes are explained. A few nights, a spike is interesting for a minute, and then it is not. The process is unhurried and measured. You begin to enjoy the phrase null result. It sounds like a quiet room after a party, or the surface of a lake before dawn. It sounds like things being okay, because they do not need to be otherwise. There is an art to building a sensitivity curve for an observing run. You collect data across many nights. Note the noise levels, the integration times, the elevations of the sources, the season, the band. You compile them into a curve that tells you what you would have seen if it had been there. It is the sort of curve that requires patience, and you have that tonight. The curve helps others plan, and it tells you that your time is not wasted. It tells you that slewing the dish slowly into a position and waiting there while the heavens move is as useful as any more dramatic work you could imagine. You think of ancient watchers of the sky and feel a kinship. Even though the tools have changed, they had their own quiet, their own feeling of the world turning. You reach a point where you need to rotate the feed to collect polarization data, and the motors that control that rotation make the softest possible sound. The feed rotates a few degrees and stops, and you record the angle. You collect another stretch of data and then switch. In doing so, you are mapping not only brightness, but the direction of the radio wave's electric field, which reveals the influence of magnetic fields along the path. You think of the lines with which artists sketch and shade. The polarization vectors on a map look like a field of grass bending in a breeze. And you like the thought that you are listening to something that will someday be drawn as small lines with small arrows, each one telling a quiet story about a place where you are not and a time that has already passed. Calmly, you check the levels of interference again. Tonight is merciful. The spectrum is clean, except for the usual narrow lines that you mask without fuss. The flags apply themselves across the time ranges you marked, and the unflagged data trickle into a storage pool that will be processed later in a more thorough way by a pipeline that has become your friend. The pipeline steps are the same each time, and the regularity is comforting. Ingest, check, correct, calibrate, integrate, image, inspect, archive. Each word falls into place like small stones in a path you walk again and again. The stones do not move underfoot. They have weathered many nights. The gentle rhythm continues. You think briefly about system temperature again, the flux from the sky, the receiver noise, the ground spillover, all add to a measured background that sets a floor. Understanding that floor is part of the job. If you know it well, you can tell when a small signal appears above it. Tonight, everything is as expected. You open a small window in the software to confirm the timeline of a calibrator scan you did an hour ago. The line is as smooth as warmed glass. You make a small note about the receiver, gain being fractionally higher than last week, probably because of a minor temperature difference. You smile because the note will be useful later, but it does not demand anything now. On a shelf nearby, someone has left a small book of star charts. It is old enough to have a sweet paper scent. You flip it open without lifting your eyes too far from the screens, and you look at the way the Milky Way is drawn there, a mist traced across the page. It is not a radio chart, and yet you can imagine the radio contours overlaying it in your mind. The book has hand-annotated markups in pencil, neat, light, and exact. You imagine the person who wrote them and give them a silent nod. We have both kept watch, you think, across different times, and that thought is soothing. If you open the door again and step outside, the dish is now facing a slightly different part of the sky. The horizon is a slow, steady line. The breeze is gentle. You hear the same soft machinery. If you imagine the light in radio waves, you can picture it as an immense, constant rain of gentle photons and fields rolling across you with nothing to do but continue. There is no drama in this picture, only peace. You rest your hands on the railing and close your eyes for a breath, and the moment holds you just as you hold it. Back with the data, you scroll through the logs from earlier in the week to compare. The days feel like they merge, not in a way that makes them indistinct, but in a way that makes them flow into one another. A night with thin clouds has a signature. A night with a strong temperature inversion has another. A night with a meteor shower shows a temporary flurry of twinkles in some bands, not as signal, but as minor interference that you recognize easily. The patterns are not hard to learn, and once learned, they become familiar as the outlines of a room you have known for a long time. You type a few lines into the log, soft words, no urgency, noting that as of this hour, the search for narrowband features at the target position has nothing new to report. Sensitivity at the expected level, nothing above a few times the noise over the baseline. The sentence is steady and complete. You read it once, and then you press enter, and the line becomes part of the record. Midway through the shift, you lean back and let your attention widen. like watching the whole room at once, and you notice that you are comfortable and unhurried. Still awake? Comment the secret word, nebula. You let your eyes rest again on the main display and imagine what the dish is gathering now. Perhaps you have scheduled a scan of a region just off the galactic plane. At this latitude, there is less hydrogen, and the brightness is proportionally less, and so the noise seems more at home than before. You appreciate that too. You remember that while the output looks like sound only because of the way software can convert it for humans, what you really hold is a record of electric and magnetic fields whispering across space and inducing small voltages in a carefully tuned system. You picture the feed horn at the focus, a simple, elegant flare that guides the waves into the receiver with minimal reflection. The geometry of it is so steady. Nothing sharp has to occur. The shape is all smooth curves. Even the bolts that hold it in place are evenly spaced, and there is pleasure in thinking of precision. Someone painted the struts a pale color to reflect sunlight and keep them cool during the day. Someone polished the readouts until they read what they should. You think of a chain of calm decisions that have led to the instrument being as quiet as possible, and you feel aligned with that approach. Perhaps you have scheduled a period of maintenance in the slow hours of the night. Maintenance is a kind of ritual too. You confirm that the limit switches are functional, so the dish cannot move beyond its safe range. You check the stow position, where the dish can rest in a wind. You check the weather forecast to be sure no gusts will surprise you. Everything is fine. The wind is a soft friend. You note that on certain nights, heavy dew can change the dish surface slightly, adding a gentle layer that shifts efficiency a small amount. Tonight, the air is so clear that nothing beads on metal. It is the sort of night observers quietly treasure. A thought drifts across your mind about coordinate systems. At the start of the night, you set your schedule in right ascension and declination, which are fixed to the sky's own longitudes and latitudes. But the Earth turns, and the hour angle of your target changes with each second. The computer handles this without effort. It is like watching a compass that always knows where north is. Beneath it all is sidereal time, the clock that does not care about the sun. You imagine that clock as a circle that turns slightly faster than your day-to-day clocks, making one more lap each year, always leading by a small and steady margin. The idea itself is soothing. There is something fresh about a clock that follows the stars instead of the sun, something cool and steady and telling. If you let your thoughts wander further, you might find yourself in a tutorial about dispersion measure and pulsars. Pulsars are fast-rotating neutron stars left by ancient acts of stellar evolution, and yet tonight you treat them gently, as if they are sleeping, because you are not collecting their pulses directly, just passing through their neighborhoods with your beam. The interstellar medium between you and a pulsar has free electrons that cause radio waves of different frequencies to travel at slightly different speeds. The dispersion measure is the integral of the electron density along the path. a soft summation of thin gases stretched across parsecs. If you wanted to, you could run a de-dispersion search over a range of trial measures, stacking the signals at different delays to see if a pulse emerges from the noise. That process is diligent and repetitive, which you enjoy in principle, though tonight you are content simply to know that you could do it. The knowledge is as good as the doing. You swing the dish by a small angle eventually, scheduled by the script, to a patch of the sky that contains a quasar whose radio brightness acts as a guide star. You keep the data rolling and confirm that the quasar shows up as a smooth continuum rise, broad and unwavering, stronger than the background by a gentle multiple. You might use it to check the pointing model, ensuring that the peak aligns with your expected azimuth and elevation. The residuals are small, a few arc seconds at most, and they drift with temperature and gravity in a predictable way. You fit a small function and let the software keep the correction in mind. You feel like you have straightened a picture frame on a wall, and it now hangs level. 3 hours in, you set up a long dwell for hydrogen mapping. In a map, you will collect spectra across a grid of points and later combine them into a cube, 2 coordinates for position and 1 for velocity. The cube is a gentle object in your mind. If you close your eyes, you can imagine slicing it at different velocities, each slice showing where hydrogen at that speed lives in the sky. It is like peeling an onion, layer by layer, revealing the structure of clouds as they move. You will do this not in a rush, but over many nights. The timescales of mapping are perfectly matched to the slow breath of a person half asleep at a console. The beam moves a little bit, stops, collects, moves a little bit, stops, collects, and in between you might blink and find yourself more rested. Out of habit, you check the occupancy of the radio spectrum around you with the station's monitor. It is a broad scan from low to high, showing where human technologies speak. Most of the time, they keep to their lanes. At certain hours, a distant airport's radar will sweep and send a periodic feature into your plots. You are ready for that. It is the sort of thing one removes with a mask or with a notch filter. In some bands, satellites form a faint line of tones that march by, their signatures rotated by Doppler shifts as they rise and set. You almost enjoy this. It feels like knowing the names of the birds in your neighborhood and recognizing their calls. Each one has a rhythm. Each rhythm can be allowed to pass. One of the oldest joys in radio observing is knowing that the sky, for the most part, is quiet enough that the universe is the loudest source there. You are grateful for that, and you make a simple note that tonight honors that tradition. When you bring up the software for beamforming or for symmetrical scans across a source, the interface is always the same. A window with coordinates, a field for integration time, a simple button that says start. You press it with the certainty of someone closing a soft cover of a book at the end of a chapter. You let the loops unfold. You are a custodian of loops tonight, and that thought makes you smile. You like loops. They repeat. Repetition is calming. The gentle rhythm continues. At intervals, you check the health of the servers that are collecting and storing the data. Their load is low. Their temperatures are low. Their disks have space. You check the checksums of the last files written, and they match. The automation that triggers alerts stays quiet, which is the best sound of all. There is a light on in the hallway that glows softly through a narrow window. The floor is clean. The plant in the corner looks willing to sleep through the shift with you. The world is holding itself together in small, patient ways. If you watch the waterfall at high contrast for a moment, you may notice faint modeling, the small-scale texture that comes from the granularity of noise. It looks like a very fine snowfall. That too is soothing. It is a random field of small intensities that mean nothing beyond the confirmation that randomness exists and that you are approximating a Gaussian process. You can make it smoother by averaging across frequency or time. You can watch it breathe. If you choose to, you can lower the contrast and the field disappears, and you are left with a very smooth plot with only the stronger features standing out. You decide which one feels more calming. You choose the smoother setting. Occasionally, a group of astronomers will run a very long baseline interferometry campaign, linking dishes across continents, timing their data so that a radio wave that reaches one station and then another can be correlated after the fact. In your mind, you picture fiber spools and atomic clocks, faint clicks of synchronization signals, time tags that are more precise than anything that enters your day outside this room. But on your night, at your station, you are not forming baselines to other places. You are listening alone, and listening alone is a pleasant kind of solitude. You are content to imagine the others doing their work in their own quiet rooms, under their own dim red lights, with their own sips of warm things, and their own gentle glances at the sky. You think about the gentle curve of a Gaussian line profile and why it fits heated gas so well. Thermal motions scatter velocities, and in velocity space, those motions form a bell. You think about Lorentzian wings and about Voigt profiles that are simple combinations. The thoughts are like soft math phrases floating by, and they do not pull you up. They simply move past like clouds. If you do anything with them, you might fit a profile to one of your hydrogen lines later to measure a temperature and a column density. You might translate the area under the line into the amount of gas along the path, and then to a mass, if the path is part of a structure whose distance you know. But you are not compelled. You have placed these tasks in a box labeled later, and the box sits on a shelf where time moves the same as it does in all calm places. The night edges along. You may think briefly of the cosmic microwave background, that last persistent whisper from an early hot epoch that has cooled and cooled until it is a uniform bath of radio light that wraps every direction the same, with only tiny ripples that measure ancient seeds. A large dish like yours does not map those ripples tonight. That is the work of other instruments. But you feel it in your system temperature anyway. It is a baseline under everything, the universe's own leftover warmth. It is a comfort to think that you are listening not only to faraway gas and distant stars that have died and left compact cores, but also to the ebbing glow of a time before any stars formed at all. In this room, with this dish, you uphold a chain of listening that spans the life of stars and more. Perhaps you think of the possibility of techno-signatures for a moment, and you consider that if someone out there sent a narrow tone intentionally, it would have to pass through many layers of medium and many filters to arrive. You imagine that tone as a straight thread through a tapestry, and you let it pass in your mind without catching on anything. Tonight, your report is simple and clear. In the section of sky you observed, in the band you monitored, at the resolution you chose, for the time you integrated, you saw no features above the threshold. This sentence returns like a soft refrain, and it builds the kind of confidence that comes from steady practice. Inside the room, the structural beams make comforting shadows on the walls. The monitors hum in registers too quiet to bother you. The air smells the same as it did at the beginning of your shift. Time smooths itself out. This is one of the gifts of observatories. They give you structured hours where nothing urgent is expected and patience is rewarded. In those hours, you come to know what quiet is, not as an absence, but as a texture that you can rest your mind on. The gentle rhythm continues. When necessary, you glance at a small graph that shows the status of RFI mitigation. A few narrow notches are engaged, as planned. You check that the automatic filters are not too aggressive, as they can sometimes trim good data if the thresholds are set too low. Everything looks balanced. You may test the configuration by injecting a tiny test tone and making sure it passes through when it ought to. The test tone appears in the waterfall precisely where you know it will, like a friend arriving on time, and then you switch it off. The record is clean again. Another look at the map in progress shows a grid of circles overlaying a rectangle, each circle representing the beam at a pointing center. The circles overlap in a quiet tessellation, and the software will perform a primary beam correction later to remove the cosmetic effect of the beam pattern across the field. Words like apodization and weighting drift into view and then drift away. You might use natural weighting if you want to favor sensitivity over resolution in an interferometric image. You might use uniform weighting if you want to sharpen features at the cost of sensitivity. Tonight, with a single dish, you are content with the natural flow of the beam. It is round and simple. It is as if the sky has been lightly pressed onto a sheet of soft paper. Somewhere, a student from years ago wrote a guide to aligning telescopes and left it in a folder on the intranet. You recall the guide and smile at a figure that shows the pointing offset as a function of elevation, a smooth curve that someone fit with a function that includes a collimation term and a sag term. The numbers are gentle. The curve is gentle. The idea that metal bends and the bending can be predicted is a comfort. The dish is strong and also human in that way, that it responds to its own weight, and you adore the honesty of that. You accommodate it with math, and the result is a slewing that arrives precisely where it should. You check the figure once more and then close the window. The hour changes. You note it. The sky turns. You note that too. For a while, you focus on the hydrogen data. Then, with a slow and deliberate motion, you switch to a wideband scan intended to hunt for spectral peculiarities across a large frequency range. The data rate rises, but not to anything the system cannot handle. You adjust your eyes to a slightly different display. Here, a faint wandering curve might tell you about a line of hydroxyl in a distant cloud. If your dish is also used for maser searches, you think of the maser as a radio laser, a place where molecules amplify radio light, and you picture a ray of energy shining through a cloud with all the precision of a line drawn by a patient hand. If you see nothing, you are content. It gives you a limit. It places a gentle boundary around what could be present. You gather that boundary and add it to the storehouse of knowledge. Moments come when you rest your eyes entirely. In those moments, the sounds of the room lift into the foreground. A faint, distant relay clicks once every so often when a stage switches gain. You can almost count the seconds between the occasional small events. Each one returns to silence. The rhythmic overhead of fans does not waver. The air moves in a loop through vents that keep everything at the same temperature. The servers breathe like sleeping animals. The boards in the racks blink with even pulses. You have learned how each sound feels in your body. None of them ask anything of you except quiet attention. It is a nice kind of attending, something like listening to rain from under a roof. A soft, alert whispers, not a siren, but a gentle tone, reminding you to perform a scheduled calibration. You acknowledge it. You turn on the noise diode for a short interval, and the measured system temperature rises by a known amount. The software calculates the gain. The plot displays the new value. You record it, and then you switch the diode off. This small act is like straightening a path of stepping stones in your mind. It keeps the walkway true. A clear calibration gives you confidence in your measurements. You have done this so many times that your hands know the sequence better than the conscious parts of you. That is good. Routine is a blanket. When you return to the waterfall, you notice the slight fainting of signal at the edges of your band, where the filter roll-off lives. You draw in the band edges a little, and the center becomes more even. You think of a camera lens that is a bit soft at the very edges and slightly sharper at the center. Neither is wrong. Each choice is just a way of seeing. You pick the settings that make you feel most at ease tonight. Soft edges, even fields, nothing that catches. Beyond these immediate tasks, a wider thought drifts in. Radio astronomy treats absence as a thing you can measure. When you say you did not hear anything, you do not mean that you were deaf. You mean that your ears were good, and the room was quiet, and the night was kind, and still no one spoke above a whisper. And your report is that the room remained quiet within the limits you set and explained. That is so often what learning looks like in science. It looks like careful sentences about what did not happen, or about how small something could be and still not be seen. It looks like teaching the next person to listen the same way. You find that thought to be restful because it lifts the burden of spectacle. You are not here to be astonished. You are here to be present. You check the radio weather once more. The ionosphere has been calm tonight, so its refraction and absorption are low in your band. The sun, far below the horizon here, is quiet in its own radio emissions. There are no flares. The magnetosphere is in a gentle mood. You note these things because they are part of your world even when they leave you undisturbed. To have these quiet watchers watching you is in itself a comfort. The earth, its fields, its layers, and its surroundings are all steady companions tonight. As a few more hours pass, you consider the care with which the dish was designed. Each panel of the reflector is shaped, aligned, and adjusted. Edges meeting edges with a tolerance you can fit between your fingers, but often cannot see. After heavy maintenance, technicians walk the surface and measure with reflective targets and lasers, and they think in micrometers and millimeters, and then they adjust jack screws with wrenches that click softly. All that care under the daylight is the reason you can sit here under the red lights and feel this level of quiet confidence. The dish is a slow instrument. Slow instruments are often kind to their users. They forgive a little. They take the shape of the sky in ways that do not fight it. You feel gratitude for this inheritance. If your observatory has a visitor center, you imagine it asleep now. Posters on the walls tell stories of pulsars and quasars and hydrogen, and during the day, those posters have voices. At night, they breathe out like old books. The gift shop has models of dishes, small and smooth. A bench sits outside where people look up and point with their hands, and their hands trace arcs that look like the motions of the dish. Even the architecture is in conversation with the sky. You are part of that architecture now, a moving mind inside a still building, beside a moving instrument under a moving sky. Motion inside stillness, stillness inside motion, one contained within the other. The gentle rhythm continues. As you approach the last arc of the night, you cue the final scans. The schedule threads through the last hour with the same composure as at the start. You set a scan across a field that will be revisited next week. You confirm the track of a source that will rise into the beam in the early morning when the air is a shade cooler again. You confirm the power levels and the states of all components. You scroll slowly through a log of warnings and find none. The display is a clean ledger of quiet. The universe does not obligate you to understand it in a single night. It offers a long stare, and it is content if you climb 1 or 2 steps with care and then rest. You have climbed your steps tonight. The absence you have measured is not an empty thing. It is filled with the weight of your attention and the calm of consistent practice. It is part of a contour you will fill out over many sessions. You feel that. It is why your breath is so slow and your shoulders so easy. You think of the word listen in a new way. Listening here is a matter of temperature and integration and background subtraction and patience. It is the art of letting the world write gently on your sensor, and of believing that gentle writing is valuable. You imagine your data file not as lines of numbers, but as a handful of sand that you slowly collected, grain by grain, soft and almost soundless, until you had enough to feel it in your hand. You did not gather spectacular stones. You gathered sand. Sand is good. Sand is what beaches are made of. Sand is the part you remember in your feet long after you leave. As the first hint of morning glows on the far edge of the sky, dampening certain bands in predictable ways, you stow the dish or let it finish its last planned move. You confirm its position, safe and comfortable in a posture that will ride out any dawn breezes. You bring your report together with the same slow care. You write that the hydrogen line was clean over the fields you mapped, and you attach the preliminary plots. You write that the wideband scan contained no unexplained narrow features above the thresholds. You write that calibration was nominal and stable, and note the numbers. You write that the system was quiet and the sky was kind. You save the document, and it nests itself in the archive. Before you leave the room, you look around once more, the way one looks at an old friend before stepping away. The lights are the same. The hum is the same. The plant is still asleep. You rest your hand on the back of the chair and feel the fabric under your palm, smooth and friendly. You take a breath and feel that you could stay, but you also feel that leaving is as gentle as staying. You press the soft buttons that dim the screens and send the system into its day configuration. The hard work is in the slowness, and the slowness is easy when you accept it. Imagine yourself walking down the corridor. The floor feels solid and cool. A cup sits washed and drying on a rack. The smells are neutral. Ahead, a door opens to a porch where the first light finds the landscape. You step out and the air holds you simply. Out there, the dish stands against the morning, a shape that looks both ancient and modern to your resting eyes. You tilt your head and listen without listening, and then you smile, because even when you listen to the universe and you do not hear anything, the act of being here is itself an answer, a promise that when there is something to hear, these quiet ears will be ready. Thank you for keeping watch with me. If this gentle time helped you drift or helped you rest, you can like this video and subscribe so these calm journeys keep arriving for you. And if you want more soft science to carry you through the night, there is a playlist in the description waiting to play on while you float. I hope you feel safe and comfortable now, with the steady sense that the universe is vast and calm around you. Settle back, let your eyes close, and let the gentle rhythm continue. Sleep well.